The small fragment clamp is ideal for fixation of fragments, such as the dorsal wall fragment shown on this sawbone model. The first step is to select the proper size for the inner component. The inner component is available in different lengths, and for a particular length, with different locations for the elbow, as shown in this tray. Often, the easiest way to select the proper size for the inner component is to simply compare it against the fracture. The dorsal wall fragment is elevated on a distally based soft tissue hinge. An impactor is used to reduce the articular surface against the proximal pole of the lunate. A burr is used to cut 2 slots into the proximal edge of the fracture site, so that the elbow of the inner component does not interfere with the reduction. These slots should be wide enough and deep enough to allow free positioning of the inner component. The legs of the inner component are placed under the fragment and checked for contact. Ideally, the base of the inner component should elevate 1 to 2 millimeters with reduction of the fragment. In the situation shown here, there is insufficient contact between the implant and the bone, with no elevation as the fragment is reduced. This situation is corrected by applying the pin bender with the central post between the lower bend at the elbow of the wire. The leg is bent up the appropriate amount. Typically, this is about 2 millimeters. If needed, the legs can be bent as well to one side if the geometry of the fracture requires it. The inner component is replaced and the contact is rechecked. The appropriate sized outer component is selected next. Again, the selection is simplified by comparing the component against the fracture itself. A gentle bend is contoured in the outer component with the apex at the intended placement of the screw and washer. This bend provides a spring effect to the wire as the screw is tightened and is important for achieving fixation of the fragment. Additional contouring of the wire can be done to fit the implant to the geometry of the fracture and to ensure that the legs of the outer component aren't directly over a fracture line. Shown here is a typical contour that can be used to allow offset for Lister's tubercle. The screw hole is drilled and the depth measured. Usually a screw 2 millimeters longer than the measurement is used to compensate for the implant and the washer. The proximal cortex is tapped if needed. The outer component is applied and fixed with a bicortical bone screw and washer. A trick for properly aligning the washer over the wire is to use the back of the thumb of the left hand to guide the washer into proper position. When the screw is seated completely, the surface of the washer should be deflected by the screw, indicating good compression of the implant between the washer and the bone. When contoured properly, excellent fixation should be achieved, as shown here.